Hello, I'm Bill Steeves. I'm a graduate mechanical engineer with over 30 years experience in the placer mining field. In the next 20 minutes, I'd like to show you a commercial placer plant concept that I developed which turned out to be highly successful. This first picture shows the feeder and screening units of the plant. Both of these units are extra heavy duty to withstand 24/7 operations. On the left is a 40 cubic yard hopper mounted over a 6-foot by 20-foot vibratory feeder. The right-hand portion of the hopper is a square tunnel with a row of high-pressure wash nozzles to pre-wash ore passing through the tunnel. You will clearly see these nozzles in action later on in this video. The second unit on the right is a double-deck screening unit. The top deck washes and scalps off all rock plus 6 inches and larger. The lower deck screens the ore to -3/4 inch. All the wash water and -3/4 inch ore then flow to the 5 sluices. This picture gives you an idea of the size of these units from seeing the 6-foot man standing on top of the tunnel. These two units were rated by their manufacturer at 750 tons per hour, or about 500 cubic yards per hour. Between the high-pressure nozzles in the tunnel and the multiple rows of high-pressure nozzles spanning the screening unit, all rock is thoroughly washed, as will be seen later in the video. One of the key features of these units is their ability to process large volumes of ore, as seen by the CAT 988 loader with a 8 cubic yard bucket dumping into the hopper. The loader can quickly dump its entire bucket and head right back to the plant stockpile for another bucket. This particular plant processed between 6,000 and 7,000 cubic yards every 24 hours with an average of 265 cubic yards per hour over a 6-year period. As seen in this picture and later in the video, this plant can wash and digest large, heavy boulders up to 5 feet long on a daily basis without damage to the units. Every large rock is rolled over 3 times to wash all sides. The facility to build these units needs to be big and have 2 large overhead cranes to lift the heavy sub-assemblies into place for proper fit-up. This last picture shows the double-deck screen unit with its piping installed for the massive water spray deck. Now let's view this plant in full operation, along with its sluices, conveyors, slurry pump, and fine gold module. Now let's look at the overall plant in operation, clear down through a typical gold cleanup of the sluices, tailing disposal, and how the various mid-grades and oversized rock are handled off of this plant. This scene here is showing the 988 loader feeding the plant. As you can see, he just dumps his bucket and the vibrating feeder starts feeding that material down through the wash tunnel. The feeder feeds the material through the wash tunnel down across the vibrating grizzly. The cross conveyor dumps onto a stacking conveyor right at the tail end and creates a bit of a dead bed for all the coarse rock, and then the material moves on up the stacking conveyor and forms a large pile that the dozer then pushes away at its convenience. All the wash water and fine material that went down through the grizzly bars there now flow out from under the screening plant and head towards the sluices. There's a wide distributor that has the 5 different veins for the 5 different sluices, and each vein splits the feed equally amongst all the sluices. Here the gold crew is just starting to do a cleanup or finish up the cleanup of one sluice, and now they're going to start cleaning up the next sluice here. The water, the feed's cut off by putting a diverter grate in. The end of the sluice, it has a flume, a pinch down flume that flows all the material from this sluice that these boys wash away into the loader bucket. And we'll see here in a minute them actually doing a gold cleanup. This process here sends the extra material that was sitting along the riffles down in the loader bucket, which will be later taken to the gold room to extract the rest of the gold from the sluice riffle material here. So we'll let them lift these riffles out. These are steel riffles, angle iron riffles, typically referred to as Hungarian riffles. And here they've got the riffles out, and the workman is starting to look over the carpet and pick out nuggets that he can readily see with his eye. And he'll generally find anything from 6 to 10 nuggets there. He's got some in his glove there showing the typical rough nuggets that were at Nome, Alaska. And at the end of the sluice, here is the pinch down flume that goes into the loader bucket, and the water, the excess water, just decants itself off the corner of the bucket. Here they're starting to wash the carpets in the sluice, and you can begin seeing the gold that was collected in the carpet and the riffles, and it's starting to show itself rather easily, and the workman can scoop it up with a square point shovel. This method of cleaning the sluices is something I developed to save the men a lot of heavy lifting of these carpets. All they had to do was just roll them over and slap them up and down on a gentle stream of flowing water, and you can see what happens. The water washes away the coarse oversize and leaves the gold trailing behind, which is easy to shovel up. This square point shovel, doing it in this manner, we found collected about 60% of the gold from each sluice, and the other 40% flowed on down the sluice into the loader bucket, which was later cleaned up and gathered in the gold room. But this is a fairly typical cleanup of sluices. That shovel probably has somewhere around 35-40 ounces of gold in it. So it is easy for the workmen to see what they're doing, and makes their work so much easier using this method versus taking everything to the gold room and trying to sort everything. There are the nuggets that the workman picked up a few minutes ago, and he's just displaying them on the lip of the bucket, the shovel, so you can see what he's gathered out of this sluice. Right down at the very end of the sluice, just before it goes in the loader bucket, they usually take their square point shovel again and the carpet and just gently roll it over, and any gold that they can readily see with their eye, they scoop it up with the shovel and put it in the red bucket, and this all goes to the gold room. But like I say, about 60% of the gold will be in that red bucket out of each sluice, and it gives the operator a very quick reading on what gold he's produced for the day. Here the the gold crew is putting the carpets back. A lot of operations use nomad carpet. This particular operator just liked the regular old AstroTurf. It wasn't too durable, and every 6 weeks or so we had to replace the carpet, but it was cheap. It did a good job gathering the gold, and it was cheap material, so it was no problem to replace it. But they're putting all the carpets down, and then they'll in a few minutes here put the riffles down and bring this sluice back online. We never shut down the plant to do a cleanup. They just shut down one sluice, divert that feed to the other sluices, clean the sluice, takes about 20 minutes, and bring that sluice back online, and then go to the next sluice, and just rotate them around like that. And the gold crew cleaned out the sluices every day, approximately the same time, just one cleanup a day, and it made for an easy operation. Here he's taken the diverter gate off of this sluice, and it's back online again. So that makes a very quick, clean setup for the mine. And like I say, the mine never shuts down to do a cleanup. Here is a good shot of inside the hopper. This particular shot happened to show this big boulder coming through. It's probably 4.5, 5 feet long. I have no idea what it weighs, but it would be heavy. And here you can see some of the nozzles in the wash tunnel starting to wash and liquefy the material that was dumped into the 40 cubic yard hopper. And right underneath these nozzles is the start of the tunnel. And this shot is showing you the workings inside of the tunnel from the discharge end. You can see those same powerful nozzles liquefying and pre-washing the ore. Here's the material coming out of the tunnel. You can see that it's well wetted, pre-washed. Some of it's very clean to start with, and now it just flows across the grizzly bars of the screening unit, and does a final wash sizing of all the oversize. Here comes that giant big boulder. You can see how wide that boulder is, how long it is. That screening unit is 6 feet wide, so it's going almost wall to wall on it, going down through the unit. And when it gets to the far end, it'll drop off into a big rock pit where the same loader will pick it up in a few minutes and take it to the backfill area. Each rock drops 9 inches coming across these grizzly bars and flips over 3 times during its travels, so all sides gets washed exceptionally well. The rock coming off of this plant is extremely clean. And then all that wash water and 3/4 minus ore goes down to the sluices and works its way down through the long sluices for the gold recovery. Here we see the scrapers and a push cat. That's what this mine used to move ore. They had 6 scrapers and operated 4 almost all the time. And the push cat would help the scraper load, and each load was 31 cubic yards, almost 45 to 50 tons per load. And the scraper would just work a figure-8 pattern, come right up by the wash plant, right up by the feeder where the loader is, and he'd dump his load and go back down in the pit. Just do this figure-8 all day long, and it took him about 7 minutes to make a round trip from the time he dumped to picking up a full load and coming back. Why, it would take him just about 7 minutes. so it's fairly fast. And the nice thing about scrapers is you can selectively mine the ore body. This ore body was 85 feet deep with 3 different pay lenses, so being able to selectively scoop up the pay lenses and send the waste, the barren ore to waste was ideal. Here the loader's picking up a load that the scraper just brought up from the pit, and he'll be feeding that to the plant here. He could do about 3 good full buckets in the hopper, and then go down below the screening plant and take away one bucket of 6-inch plus rock to the backfill pit. The scrapers, we had a full-time geologist that constantly worked with the scraper operators and the pit superintendent to make sure we were in pay or out of pay, and the geologist was constantly sampling, panning, and training the men to identify the different colors and shapes of rock, so they would pretty much know if they were in pay gravel or barren gravel. Here there's 2 scrapers waiting directions from the geologist so they know what they're hauling. Here comes the loader. This is the same loader that just put ore in the 40-yard hopper. He's down to pick up a load of the oversized rock, and you can see some of the size of some of the rock. It gets good size, and he'll transport this over to the rim of the pit. We're just moving a hole. We'd mine on the far side of the pit and backfill on this side of the pit. So he would dump this coarse rock, and you'll see that in just a minute, over the rim of the pit. And then coming behind this coarse rock, the dozer would push the fines from the stacker conveyor, so it made for easy reclamation. Here we're looking at the coarse rock that the loader's dumped over, and you can see it flowing down into the bottom of the pit. This is another shot of the overall plant. Here the loader is feeding the plant, and we'll see the material coming down through the sluices here in just a minute. The plant would handle 265 yards an hour on the average. We washed 6,000 to 7,000 yards every day, and this went on for 112 to 115 days every mining season. This operation was at Nome, Alaska, so your mining season's merely in the summertime. The sluice tails were brought down and put across another horizontal vibrating screen to scalp off all the plus 5 millimeter minus 3/4 rock, and that was put on the conveyors here, which took it out to the stacking conveyor, and all of that material would eventually be dozed back into the pit by the dozer there as part of the reclamation. But here you can see the sluices operating, and at the end of the sluice was just a big trough, and all their flow would then flow down across this horizontal shaking screen. And this is just a single deck screen fitted with slotted urethane panels. And if you notice how quickly the water and the slurry goes down through those screen panels. And the underflow of this screen was pumped by a slurry pump over to our fine gold module, which you'll see here in a few minutes. But this horizontal screen scalped off all the, essentially like pea gravel, all the plus 5 millimeter, which is about 3/16 material, through the slotted screens, and did so very efficiently. And there goes the plus 5 millimeter minus 3/4 rock out to join the other main conveyor going out to the stacker belt. This horizontal unit had two overflow water systems on it. The hopper was kept slightly overfull all the time so that the pumps would never suck air and cavitate, but if something should happen to the slurry pump, these two valves, one would open and the other would close. One on the left would open, and all the flow would go right out to the tailings. And then when everything was fully operational by this slurry pump, which was driven by a John Deere diesel engine, powered the slurry pump and pumped all the minus 5 millimeter material and water to the fine gold module. Throughout the plant you'll see these green filters, which are from the ag industry to screen out any vegetation and debris. This is the fine gold module that all that minus 5 millimeter was pumped to, and the top tank is just a water scalping tank, because there's a great deal of excess water coming off of sluices. And then the underflow of that tank was fed down into 4 38-inch high-G mineral centrifuges, and these extracted and scavenged the sluice tails for any fine gold that they lost in discharge. And this is a picture of myself explaining to folks all the valving and distribution of material that went to the 4 high-G units. And each high-G unit could be shut off independently for clean out and maintenance. This is the size of the typical high-G unit that you just saw. It was mounted on there before these on that fine gold module, and this worked